Consistency.
Hello, good morning. How's everybody doing?
Hello,
Good
good morning.
morning. I'm seeing here a few people start entering our platform. Thank you for joining us this morning. We are Silmar Electronics International presenting today Li-ion Tamer solution with our partners from Honeywell Fire Solutions. With us is Veronica and David. Good morning, guys. How are you?
Good morning.
Good morning, Karen. Thank you very much. Um, I don't know, Karen, do you want to give like instructions on how to raise questions
Yeah, we're gonna
or
do it. I was waiting for you to introduce David, but it's okay.
okay.
We are
Okay.
recording the session as well, so we will send it in a thank you email this afternoon with all the information so you can review it or share with your colleagues at the office or customers that you think this information would be very helpful. We're gonna be here for 35, 40 minutes, more or less. And at the end of the session, you can text on the chat box your questions, and then we're gonna read them for Davy and Veronica. Or if you have any questions about distribution, I'll be here hosting and reviewing that information. So thank you for coming today and being here with us.
Yeah. Thank you, everyone. My name is Veronica. I am your senior territory manager for the region. And as Karen mentioned, we have David, our Lion Tamer specialist, which is going to talk to us a little bit about how lithium-ion batteries work, what are the risks of them, and how we can prevent those explosion risks. So hope the meeting is helpful for you, and please feel free to raise any questions. This is the time to clear all the questions. David?
Well, good morning, everyone. I think everyone's on Eastern Standard Time. So, good morning, everyone. We're going to talk about the Li-ion Tamer. We're going to start with the Gen 3 system, and that's for energy storage systems. And we'll see some applications for that in a bit. And then I'm going to introduce you guys to something that I'm really excited about that's coming out next month called the MOS, which is called a multiple output solution. And we're going to touch base on that because it will be available for everyone starting next month. And it is a great product for smaller applications when you only need maybe one or two sensors. So we're going to start on just a quick presentation to bring everybody kind of just up to speed as to Li-ion Tamer itself and lithium-ion batteries. So here's some of the stuff that we're going to learn about. We'll talk a little bit about gigafactories. Not much. It's not going to be a huge thing in your markets. Recycling is going to be a big thing. Energy storage, the actual shipping and storage of the batteries, and telecommunications are going to be the big markets in your all's area. So let's get into that. First of all, how does a lithium-ion battery function? And we've got this is a 1,000-foot view. There's a lot of chemistry that goes into this, but for our purposes, this is the basics of it. On the right-hand side, you'll see we have a copper anode, and then we have another metal, could be nickel, cathode on one side and an anode on the other side, and we have a separator between them. And basically, if you look at it as one side's positive, one side's negative, we're sending free lithium ions through that separator to the other side. As we're charging it up, it will send them over to the right, and as we're discharging them using in our cars, in our toys, in our drills, and all this stuff, then we're sending them over to the left-hand side. But in order to get from one side to the other, we have to pass through this separator. And that separator serves a very, very important purpose because without it, what we have is a negative side contacted with a positive side, and that creates a dead short, which is what triggers the runaway and fire event that we all get to see on the news every single day, it seems like now. So this separator is made by a polymer and filled with an electrolytic solvent. So what happens is as that battery starts to heat up or as that separator starts to become weakened, it converts that liquid solvent to a gas. And as it overgasses, then we have what we call a initial cell venting. And you can see a video or a picture of it up here in thermal imaging. And so as that separator breaks down, we turn that liquid into a gas, and we overpressurize the canister for a cylindrical type battery, or we overpressurize the pouch type battery, and one of the seams will give away on the pouch type batteries. So what happens then is we have electrolytic solvent vapors that are discharged, and that is what Li-ion Tamer is built to pick up. Now, we have the studies, we're going to see them here shortly, about what happens after that process takes place, and if you don't do anything, how that separator breaks down, and then you go into thermal runaway. But there's ways that we can prevent it. Speaking of prevention, we have, look on our outside ring here, we have a preventative region. That means we're preventing the thermal runaway. The containment region, still valuable, still something we want to look at, but that is exactly what it says. It's containment. We're not going to stop the thermal runaway. Once the runaway begins, there's no way to stop it. It's going to go until it consumes its entire fuel source. So as it's going around here, you'll see we pass the smoke, we go to fire, but it all starts here at the top, the battery abuse. So first of all, we want to talk about battery abuses, and that is the thermal, electrical, and mechanical abuses. Thermal abuse is heating the battery, overheating the battery. We've all seen the warnings on our cell phones. It says it's overheating and it's going to shut down certain applications to stop taxing the battery so that it can cool back down. Electrical abuse is exactly that. It is overcharging the battery or rapidly charging the battery with too much amperage of current. And then there's mechanical abuse, which is something that's outside of our purview. Mechanical abuse is physical damage to the battery. We all remember the Samsung Note 7 that physically would bind itself inside its housing and catch fire. We've all seen the videos of the guy dropping the weights on his cell phone at the gym, and it poofed to smoke and then went up in flames instantaneously. That mechanical abuse is an instantaneous breakage of the separator. That means we're not weakening it, we are physically breaking it all at one time. So that type of abuse is not what we are looking for. There are mechanical means to protect the batteries, and that's a much better solution for a mechanical abuse situation. But for thermal and electrical abuses, that's where Li-ion Tamer lives. So I've got the word off gas here at the 3 o'clock mark on our preventative ring. That really should say initial cell venting. It is an off gas, that is correct. But at 6 o'clock here, where it says smoke, that also is a off gas event. We are off gassing a lot of different gases at this point down here on the bottom of the circle than we are up here. These are the electrolytic vapors. This is some carbon monoxide, carbon dioxide, hydrogen, and some other LEL gases and whatnot that happen down here, but they're both off-gas events. So we're going to focus on the initial cell venting. Now we're going to play a video here. You guys should be able to hear and see it. What you're going to see is this is a thermal. This is a heat wrap blanket around a cell, and we're just going to overheat this battery. You're going to hear a pop, and then you're going to see a little splatter of liquid up here. It's going to evaporate within just a couple of seconds, and that should be it right there. So we're going to go ahead and hit play. We're going to hear the sound of the fans in the background. There's our pop, and we had a splatter out here. It looked like water and evaporated very, very quickly. We are going to do it one more time, right up in this general area. What you see there is the electrolytic solvent. You can't see the vapors because they are invisible. You can't see them with the naked eye. Had we had a thermal imager on this, we would see the splatter like you've seen in one of the early screens, and that would provide you a kind of a full idea of what happened. So as that purged and went out of the weakened spot on the battery, it took some of the fluid with it, and then it evaporated away. It's very important to understand that this is not a particulate matter. It is a vapor. much like a cologne or a perfume. If we put a Vesda system in my office here and I break a bottle of cologne on the floor, I'm going to be smelling it for weeks. But the Vesda system is not going to care because Vesda uses a red laser, blue laser, anything that uses those red lasers or blue laser or red light, blue light technology for the light scattering principle is looking for particulate. There's no particulate in the vapor. It's not what it's looking for. So in this case, a Vesda doesn't care that this just went off. But what we just seen, we're going to play it one more time because why not? What we're about to see is this right there. And we are in the preventative ring. So if we detect this, we can now prevent everything else on the chain here. We can prevent the smoke, we can prevent the fire, and basically the total devastation. We see some videos coming up here next is what happens when you don't have Li-ion Tamer. So what we're going to do here is we see our smoke propagation. We see it a little heavier here. So about 5 seconds to 10 seconds of smoke. We're going to play it, and this is how fast it goes from smoke, once the smoke hits, to when you get to fire. There it went. At maximum 15 seconds. At maximum. Probably closer to 10, but at maximum 15 seconds from the time the very first smoke came out to what you're seeing. I'm going to get over here and ready for the pause because it's very important. Oh, clicked the wrong button. Here we go. There we go. That's the result right there. From that fire, now had we had Li-ion Tamer in there and we picked it up on its initial cell venting, we could have shut the room down. They would have had to go in, pull that section of batteries out, replace that section of batteries, and then recycle the one that just that went off. Then they flip the switch and their system's back up and running. Unfortunately, they didn't have that in. They could have had Vesda. They could have had Fike has, or not Fike, Siemens has a device out there, which I've got some paperwork on. We'll see that in a bit. Or just smoke detection, or they just use carbon monoxide or hydrogen detection. And all of those things are present over here in the thermal runaway status. So once it gets there, there's nothing that we can do. Once it triggers this point, it's about containment. So it doesn't look like they had proper containment here either. As you can see, we have 100% loss on this facility. The entire place is gone. And I want to go back and point out that this was not cheap batteries. This right here, that's the Samsung logo right there. These are good quality batteries from a good quality manufacturer. But there's a lot of things that can go wrong between thermal and physical and electrical abuses to the battery. So we're going to go on. And I have to apologize right now to Veronica. Veronica fixed this slide for me, and I have not cut and pasted it in here. So apologies to Veronica. But this line is the one we're talking about. She fixed this line for me. And we're going to see this line actually comes over here flat and then shoots kind of straight up right here. So the VOCs, the CO, and the H2 are here, and they go up. But at the outset, when you see that first venting, we have a lot of electrolytic solvent vapors, 45%. So if we're trying to test for, if we have detectors for hydrogen out there, which is a big deal, a lot of people like to do that. It does suit the LEL factor. That's great. We're only putting out less than 0.1% hydrogen at that stage. It's not going to detect it. Carbon monoxide is 0%. There is no carbon monoxide released at this stage. So your CO detector is not going to detect it. And the rest of it's water vapor and a little bit of carbon dioxide. And you can see on the next screen, you can see a little fluctuation on the carbon dioxide. So let's go take a look at that. Here we're going to break down the gases and the time frame. That first venting we see is right here at 810 seconds. All the other gases, all the other gas monitors, CO, hydrogen, carbon monoxide, carbon dioxide, carbon monoxide up here, and your LEL gases all happen right here. We have a little bit of let's see here, what's our blue line? A little bit of hydrogen here beforehand, but not necessarily in the amount that we're going to be able to pick it up on a sensor. These are all field calibrated for the test that we were doing. So we got a little flutter here with hydrogen. And your CO2, the midline is here because that's just the ambient 320 parts per million of CO2 in the atmosphere. So as you can see, right here was where the first venting went off. Right here's where the second venting went off. Let's see what that looks like in real time. 13.1 minutes. This is where Li-ion Tamer goes off. This is where all the other gas detectors go off, is at second venting. So your alarm thresholds, you can see, there used to be an imaginary red line right here, and it just goes straight up and down. And once you hit that red line, there's no going back. Once you hit that red line, you are losing whatever is there is going to burn. There's no way to stop it. All you're doing then, if you remember back to the rings, all you're doing then is trying to contain the fire and hope you can stop it from propagating to the next one and the next one, which is why we call it a runaway. So we're going to take a look here, and we have our our signal for the Li-ion Tamer. We heated the battery up. Li-ion Tamer went off here at 30, looks like 31 minutes there. It's got some more data on this. If anybody wants these test results, these are not from Honeywell. These are from a third-party ESRG test report. So if anybody wants these, we can provide you links so that you can use them. You also have, you guys will also have access to this presentation as well. But here we go. We left the battery warming. We continue to abuse the battery, and we pushed it into thermal runaway. Down here, we said this is just detection. We're just telling you when it could have stopped. Down here, we're going to do mitigation and say, hey, when we detect this off gas, we are going to stop the abuse. That's all we did. We didn't pump in tons of fresh air. We didn't spray any chemicals. We didn't discharge any aerosol. We didn't do anything except stop abusing the battery. In this case, was we had that heat, the heat wrap was on it. All we did was stop heating up the battery. That's all we did. So right here, as you can see, we're heating up the battery a little faster at this point. We have our off-gas detection. We stopped heating the battery. Temperature returned down, and the battery never went into thermal runaway. We have multiple tests for that. Again, these are not from Honeywell. They're from Nexaris. They are from a third-party ESRG that is a testing lab. So now that we know about lithium-ion batteries, the generality of how they work, and how they go into thermal runaway, we're going to talk about the Li-ion Tamer system itself. So I'm not going to read this to you. You guys can all read, and you have access to this. So one of the things I do want to point out here, I love to point this out, is it's the low maintenance. These are calibration-free sensors. They have no requirement to go in with calibrated gases. Your CO is required to be calibrated. Your hydrogen is required to be calibrated. Your LEL gas detections, your CH4s, all of those have to be calibrated and done on a cycle, and they have a generally shorter lifespan. So these are low maintenance. All we are doing is you buy this it's a little bottle, you do a little bump test on the system, it tests it out and lets you know that it's fine, and you move on, and that's good for the next year. If you're in a really harsh environment, we may recommend doing that on a 6-month period, but depending on I haven't seen one yet. That would be more of a ESS system located in a very heavy manufacturing location. But even then, most of those battery racks are located away from the hazard areas. So we're still keeping it around a year. But the big thing is quick, simple test. Calibrating sensors, calibrating your test equipment, calibrating your gases, all of that stuff adds to it. The lifespan of this unit is 10 to 12 years, which is the same on purpose as the life expectancy of a lithium-ion battery pack. So if you have a full healthy lithium-ion battery pack, this sensor should last for its entire life. So key features you see on the left-hand side, and we see some target applications on the right-hand side. Again, you guys can read, so I'm not just going to read these off to you. One of the things I'm going to highlight is down here we have gigafactories. Gigafactories are nice, they're great, but they're not really going to be in your all's market. But telco and data centers are going to be heavy. Telco is making a big move to that. As they're moving from lead acid batteries, they are picking up lithium ion to take the places. One of the main reasons for that is power density or energy density. They can get in the same space a lot more power than they did. So they can actually shrink their footprint of their battery room, increase the footprint of the things that generate revenue for them. And so it's a win-win for them, and it's a win for us. And if we have Li-ion Tamer in there, it's a win for everybody, because now we're keeping it from going into runaway, and we're not having all the pollution that goes along with it. Automobiles is on here. If you have a car park or something along those lines, contact me directly, or contact our boys at Nexeris or our field applications engineers, which are available to all of you, and let us talk to you about it. There's very specific applications that we can use this in for charging bays, and it's not made for everything. So if we have one of these parked right next to a diesel truck, we might have problems with some alarming issues. So those are the kind of the core markets that we are focusing on and that utilize the technology. We're going to talk real quick about the system layout and designs. And I said my first time that I put one together, I didn't read the manual, of course, because that's what we do. And I turned the system on, I went to the IP address, and I programmed it in less than 10 minutes. And I set one up, and I have a training video that I recorded yesterday on how to do this. And I found out that I could probably program a 10 zone or a 10 detector system in probably less than 10 minutes as well. It's extremely simple. There's not a lot to it. We're working, again, like I said, we're working on training videos that we can give out to everyone. The biggest thing here is, unlike a lot of our products where you have to have a resident software on your computer, you don't have to do that anymore. You can take any computer. If from an ESD standpoint, when you sent Steve out to program it originally, now you got to send Brian out behind him to make a change. They don't have to share files. They don't have to worry about what's left on site. They log in, they make the changes, because all of it's on a web server that's built into the controller. So it makes it very easy for changes. You can have multiple users, and you can have either an admin user or an installer user. So it's really easy to set up. Now, I love telling on us for this, because we have a video that these two images were pulled out of. And on the one that catches fire, it's death and destruction. But on the one where you use Li-ion Tamer, it zooms out and it's got all kinds of butterflies and things flying around. So I always like to make fun of us for being so corny with our butterfly use on our videos. So over here, we're going to talk about asset protection. That's great. Nobody wants to lose their assets, but that's actually one of the lower things on people's minds. Business continuity is one of those top tier things. So if you have a cell tower out and about that's covering, X amount of square miles of space, and if it goes down, you've got a lot of customers that are without service. There's a lot of problems. You can lose a lot of revenue from a telco, cell provider, something like those. From their standpoint, the B2B or the Internet of Things is real, and there's a lot of stuff that communicates nonstop through those channels. So keeping them up and running is huge. We do have some insurance companies that are allowing lower premiums, and then the amount of toxic chemicals that go into these, and the abuse that we put on Mother Earth to begin with to make them, It's a poor return if we just allow them to burn up and go right back into the ground and contaminate areas, because if people are just hosing these things down with multiple chemicals themselves, and plus the water that's just washing it away. So none of that's a good thing. But I saved my number one for last is life safety. You know, if I was in one of these rooms, and I used to be a field guy myself, if I were in one of these rooms and I heard a pop like we heard in the video when we overheated the battery, I would not have a single clue of what that was. Not a clue. I would just assume that it was a contact changing state, and I would move on about my life until I seen what we got to see in the video when it flashed over. Then I'd be running like crazy and hoping I could get out. So there's a lot to be said for the life safety, not only of the people that service it or could be in those spaces, but our first responders as well. Because if we let these burn and we let these things off gas, we can build up LEL gases, which now we're moving from just a fire event to a possible explosion risk. So we don't want any of that, especially in these confined spaces. So we've talked about this again. I want to drive it home: energy storage, data centers, gigafactories, not so much. There are a handful of them come over here. EVs, again, that's one of those areas that we do a very specific. We can do it in this situation, but not in that type of situation. So here's some of the little feathers in the cap. Talk about the United States Navy installation on military platforms. And that really is number one because this was actually born from the U.S. Navy and Nexceris, who's a key manufacturer on the product, through Honeywell back in 2010, 2011, somewhere in that circa time frame. The U.S. Navy awarded Nexceris a contract to investigate lithium-ion battery fires and to discover a way to detect them and a way to basically prevent them. And the Li-ion Tamer is what came out of that project. So this was actually born from them. So we love to have that one up there on number one for our feathers in our cap, because it really was born from the United States Navy. And anytime that there's a battery unit on one of those boats, you're probably safe to assume that Li-ion Tamer is not very far away from it. The rest of them over here, you guys can see that the 270 projects. This is old data. We have a lot more project feathers in our cap than that now. So next up is we're going to talk about a couple codes. Now, we're not going to focus on the fire codes, which is something that we are all kind of used to. I mean, we live in those fire codes. We're going to talk more about the hazardous materials codes because, as I just touched upon it earlier, there's a lot that goes into these batteries. And if they catch fire, or if they vent, or if they go into runaway, they release all of that stuff back out, and in some cases, much worse. So we're going to talk about the IFC, and it covers just general provisions about controlling and the handling, storage, the processing, disposal. This is going to be your recycling plants and things of that nature. So we have preventative scopes in the IFC, and it calls out specifically the detection of gas or vapor release, which is exactly what that initial cell venting is. It is an electrolytic solvent vapor release or venting. So even without being part of the fire code, the requirement for detection of vapor release is already required in IFC section 5001. You guys can see the extended dots there. And we're going to move over here to NFPA. This is NFPA 400. This is the 2022 edition, which I believe is the latest. And you guys can see here, we do have flammable solids. These batteries are flammable, highly flammable, as proven by, again, the news almost every single day. And then they are very toxic, the stuff that is released out of them. So this is going to be, this is the general outline of what 400 is going to cover. Now it gets into, you guys can read into the dots here about specific codes. That electrolytic solvent vapor, that actually is classified as a flammable gas. Thereby being a flammable gas, it is now should adhere to NFPA 400. So in the areas that you guys are in, if you all are following the NFPA or if you're following the IFC, there are already codes in place that require the use of something like Li-ion Tamer. Unfortunately, or no, I guess fortunately for me, there's nothing really quite like Li-ion Tamer. It kind of stands in a class of its own. Here is the release of hazardous materials. And this talks about the release into the atmosphere. So a little more refined. I'm going to bounce through some of these because I want to get over to the questions because I have some other material that I think will be handy. Plus, I want to talk to you guys about the MOS, which is coming up next month. So we're going to go through these indoor. There's one in here I do want to pick up right here. Recirculation shall be permitted when it's monitored continuously. So just so you guys understand fully what this means, if somebody has a lithium-ion battery system that has the capabilities, and they all do, even if it's LFP, don't let anybody fool you, LFP batteries, lithium-ion batteries, whatever they want to call them, they're still lithium-ion batteries, and they still release very dangerous and hazardous chemicals. So recirculation shall be permitted where it is monitored continuously, meaning they have to have something that's going to detect that initial cell venting in order to have recirculation. Now, let's take a look at just a moment and let's dig into what that actually is saying. If you're not using Li-ion Tamer, you are required, or something that's picking up that initial cell venting, i.e. Li-ion Tamer, you are going to be required to bring in fresh air and expel conditioned air 24/7. Now, in certain parts of the world, that might not be so bad. Running a unit on economizer, bringing in 100% outside air and purging 100% inside air, that may be worth it. I live in upstate New York. During the winter, it's a little cold. During the summer, it's a little hot. And you guys are down in the Caribbean. There's probably a good bit of temperature swinging there, but also humidity because we got to keep these things dry. So now we've got a highly conditioned air coming in and get the moisture out of it and get it to the temperature that we want to operate in for our facility or our batteries or wherever these batteries are located. Instead, and just from a energy consumption standpoint, that's a lot of energy wasted just to do something that we throw in Li-ion Tamer. Now we can start recirculating the air, and we don't have to worry about that heavy conditioning of the atmosphere. So let's see here. This is the 400. This is just more life-saving mitigation of fire spread and explosions. The idea here is to prevent fires, which is exactly what Li-ion Tamer is built for. It is the preventative part of the ring so that we can prevent it from going to run away, so that we can prevent the fire, so that we can prevent the explosion, and prevent me from having to say prevent 15 times in a row. That is the end here. Here's one of the core takeaways. Initial cell venting. The reason we want to drive that home is that, yes, it is an off gas, but off gas also describes other stages of the breakdown of a battery as well. So we want to focus on initial cell venting or the electrolytic venting. That will drive home specifically at what stage. Because if you're an end user, let's say we have an owner watching this, if you're an end user and you just say, oh, I need to have off gas detection. Off gas detection means multiple stages. You can have off gas detection at a prevention area, and you can have off gas detection at the smoke area, and you can have off gas detection at the flame and fire area. So off gases throughout the cycle, we want to pinpoint exactly what we're talking about. So here we go. We're talking about our facilities of where we can install these. And then, of course, as always, how many orders can you send to David today? And the answer is all of them. So that is that. And that's the end of my jokes. I'm just kidding. I joke a lot. So there you have it. Does anybody have any questions on the Gen 3 system? I don't know where the questions will come
Hi,
up.
David. We have one question.
All right, shoot the
This
thrill.
is, yeah, what suppression system can be used with lithium-ion batteries?
Okay, that's a great question. There is a company called Fike that is working on a chemical right now called blue. And when blue comes out, which is not out yet, when blue comes out, then we will have a chemical that actually is proven it is what it's supposed to do. It again is not necessarily to put that fire out because again, once that fire is triggered, it's going to consume whatever fuel is there. But we can stop it from propagating to other batteries so that the cell that's in the middle doesn't ignite the next 4 cells around it and they ignite the next 32 cells around them and so on and so forth. So that is there. As of right now, there is no chemical that I would put my name on and say this will put out the fire. There are some people out there that will tell you there's some like StatX, I think, has one that I see some people use. The only problem, well, not the only problem, because again, it can't put out the fire. Plus, if you put something that's corrosive on your equipment, you're going to be replacing your equipment anyway. And what did you solve? You didn't solve much. So the idea is to use Li-ion Tamer for early detection in the preventative part of the ring so that we can stop it from happening to begin with. But right now, there is no chemical or agent like FM200, Novec, Halon 1301, Halon 1211, FM2, I think I said FM200, Novec 1230. None of these chemicals, and I have actually been to the test years and years ago when we tested all of these, and one of them did better than others at knocking down the fire, but then every single one of them, including the dry chemicals, the water mist, all of them, once we took that suppression away, and it still just sit there and smoldered. And the moment it was out, it burst. The moment the suppression stopped, it burst right back into flames. A lot of words for a simple question. I could have just said no.
No, that's okay. That's okay. That was great.
Okay.
I don't have any more questions so far.
Okay. So I want to drive home the difference between particulate and vapor. So what I've got on the screen right now, and I'm not going to run it in the full power. I guess I will. Be better for you guys. Let's see here. This is, for some reason, it started me at the end. Let's go to the beginning. Now, I'm going to skip through a lot of this because a lot of this is stuff that's been pulled and used in the other presentation. But we did an analysis for competition for battery failure, and we used Siemens and our own Vesda, and we have commercial gas detection here for detection. Now, we all know these two guys right here, when it comes to smoke, these two guys right here are on top of it. When it comes to certain gases, this guy over here has got it all day long. The problem is all of these function at the red line, which is our thermal runaway line, and to the right. Whereas Li-ion Tamer, and this is an old Gen 2 system, I need to replace that picture, old Gen 2 system, but this functions to the left of it. We've already been over this. We're not going to do it again. We're going to talk about the setup. As you can see, we have a single pipe with a single hole. Now, this is ideal setup for both the Vesda and the Siemens FDA. So both of those, these are ideal setups. Short length of pipe, one opening. That's it. It's one pipe opening. This is what we did. We did an LFP just in case, because it is a big thing. A lot of people think that the LFP batteries can't go into runaway. They absolutely can, and they absolutely do. So we have our NCA, our LFP, and our NMC over here. You guys can look down here for the definitions of those. Our capacity of amperage, how we treated it. We overheated it. For the LFP, we overcharged it. I will give LFP this. It does have a little higher tolerance when it comes to the heat. but we overcharged it, and we overcharged the pouch as well. And this is kind of the rundown. I'm going to blaze through these things pretty quick. As each one of them, you guys can see the time frame, the difference on the time here at 1650. You got about 9 minutes of early warning on that one. That was the NCA. And then here's the competitive analysis between the VESDA. Now, VESDA, that's the VEU. That's the most powerful smoke detector on the face of the planet. And as you can see, that orange line and that blue line are kind of stuck right on top of each other. This is, I mean, that Siemens, that FDA 241, that's a great product, again, for particulate detection. Here's where our gas detection failed, or our gas detection detected the off gas here. Here's our Li-ion Tamer response back here. Here's that red line back there's my imaginary line. What we need to be is on the left-hand side, so we can prevent anything at that line or further is a containment. So here's the LFP right here. This is one I love to show. We gave it 13.2 minutes beforehand. This is a 280 amp hour battery. So this is not a baby battery. This is a big guy right here. And here we go. We have our Li-ion Tamer response. No dilution, FDA. Again, we're setting right in here. So we get a little bit of stuff right here. That's good. That's good. Our VESDA and our stuff here is coming out. We don't know what the response would be if we shut the power off here, but we got a little bit here. But back here's where Li-ion Tamer went off before any of this runaway can start. They did pretty good on that one. And then here is our gas detection, our commercial gas, the LELs and so on. And as we can see, the thing I want to point out on every single one of these is the distance from where Li-ion Tamer goes off to where the runaway event occurs, and when all of the other equipment. This is the NMC. This is the pouch for Li-ion Tamer back here. And then over here is where the other two devices went off. So it does show that on the LFP, the big LFP batteries, we can get a little early detection, but we don't know if it's early enough to prevent a runaway. So we have carbon monoxide. This is on that pouch right here. Overcharge is the abuse. And again, look at our time frame difference on this. And our green's carbon monoxide. We got just a little flutter of carbon monoxide here. That's it. So again, that's all I'm going to go over right here. That is 100% available to you guys for your use. And I want to show you.
The MOS.
I want to show you something. There it is. I have all the other tabs open on the other screen, and they're all buried on top of each other. Okay, this is the MOS. This is coming out next month. This is a multiple output solution. So we have a single sensor that plugs into an RJ45 port. And from
David,
that, we have, yeah.
Can you zoom in a little bit that it looks very small?
Let's see here. How do we? Oh, there we go. Let's go one back. How's that look?
Much better. Thank you.
Okay. So this is the multiple output solution. This is the LT-SEN-MOS. MOS is multiple output solution. And, these are for small confined areas where we have one sensor. This right here, one sensor. Now, because of its location, or we may have a slight delay, but with the amount of time that, a very confined space is going to give us for batteries, we're protecting 6 racks right here with one sensor. What I want to go over is we've got these sensors plug in from an RJ45 on the back. They plug in RJ45 into the controller. We have 2 alarm contacts here, and we have a fault contact. I believe these are normally open and the fault is normally closed. They are not programmable. So if you got to interface with them, you may have to do a separate relay for interfacing. On the other side, this is our DC where the power comes in. We have 485A and B, that is Modbus. So we have a RS485 Modbus communications port, and we have a CAN bus, low level, high level. So we have CAN bus communication as well to interface with building automation systems or battery management systems. So this is coming out, like I said, this comes out next month and is available to everyone. The price point is very good. Let's see here. There's our relays, kind of our data about it. Target life, 10 years. This is a draft, so don't pay too much attention to it because this will be, if I get the right paper, UL, and I have the right paper, but I've got stuff sitting all over top of it. 2070, I don't need it. It's going to be UL 2075 listed, which will give you the explosion and stuff that you need. And I believe it's going to get UL 69 as well. So there's a lot going on this, and this will be a great solution. Think of small cell towers, which are everywhere, and now we can walk in with a single, in the palm. Actually, I got one of the controllers right here, one of the brand new controllers. I had them send them over to me early, and I've got that, a sensor, and you're off to the races on those. So it's going to be a great thing to have going forward. So wraps me up, and I don't know how to stop presenting, but oh, here it is. Stop sharing. There we go. So from there, I don't have anything else to show you guys unless you have some more questions. So hopefully everybody's thought really hard and got me some questions, and hopefully one of you guys try to stump me.
Thank you, David. We have Derek James raising his hand. So I'm going to open for him the microphone so he can make his question, okay?
Okay.
Hi, Derek. Good morning. Can you hear us? You just have to unmute your microphone and we can hear you. I give you the access to speak directly. Your microphone is still on mute. If you don't have any mic, you can write on the
Yeah,
chat box and we read it for you.
Yeah. Yes. Good morning again. Are you
Hey,
hearing
there
me
you
now?
are. Yes, perfect.
Right. So I wanted to know, is that module, is it compatible with any fire panel?
so due to the relays, you are able to attach it to any fire alarm system that you want. Because it's fully contact closure. So
Right.
let's say you have, it doesn't matter if you're Notifier, Gamewell FCI, Simplex, EST, Potter, doesn't matter what your brand is, you're going to use an input monitor module and just watch the relays on the unit for alarm, and we'll give you a normally closed for fault.
So it could work for 2-wire and 4-wire smoke detector uh, panels or no?
Oh, okay, for like a conventional system.
Yes. Yeah.
So because it has, so yes, you could work it out to where you could use one conventional system zone, series the end of line resistor through the normally closed contact, parallel it
Right.
with the alarm just like we used to do when we monitored like clean agent suppression systems and things like that. It'll function exactly the same way.
All right. Also, I also interested in getting a certified for a conventional fire panel. Do you all give those certification?
So you can work with Veronica,
Yeah.
and she can get all that stuff arranged for you and find out exactly what it is you need and find a solution for you.
Okay. Thank you.
Thank you,
Most welcome.
Derek.
Okay.
Actually, we have one coming in October with
Okay.
firelight alarms here in
Mm-hmm.
Miami. So I have your email. I will send you the invitation. Or maybe you're ready to receive it from Silmar Marketing, but
All
don't
right.
worry. I will send you the information today.
And that will be online, that I could be certified, get certification.
No, that one will be here in Miami. It will be a physical training, but if you need an online one, I can send you the Honeywell University links where you can take those as well.
Okay, well, yeah, preferably that for now. Yes.
Okay, understood. Thank you, sir.
Okay, thank you.
Somebody
All right.
else want to raise your hand
Any other
or
questions, comments,
type
concerns?
type any questions?
You guys are making this too easy on me today. All I had to do was talk.
Well, so far we don't have any more, and we
Excellent.
already completed almost an hour. So I want to be mindful about everybody's time. I appreciated your coming today. I want to thank David to making it so easy and fun to go through this information. Thank you, Veronica, for putting this together. Sending regards to Rodrigo Mena, who's also joined us in the webinar. So that be all for today. Thank you so much to everybody.
Thank you, guys.
Bye. Thank you.
Thank you, everybody. Have a great day. Bye bye.